So now we have multiple factors of different bases underneath the radical. In part D, simplify the square root of 72, a to the 4th, b cubed, c to the 10th. Well, it's really like 4 problems in one for each factor, if you compare it to what we've been doing. But we're not going to break this up into 4 separate radicals. We're just going to do it all underneath one radical. Here, let me show you the method. First of all, let's handle the 72. So the 72, how does that break down? What 2 numbers multiply together make 72?
2 cubed, 3 squared.
Okay, so 8 and 9 let's start with. 8 times 9. And then, yeah, you're right. 8 is 2 cubed. We've seen that. And 9 is 3 squared. So 72 is 2 cubed times 3 squared. Now, we're looking for perfect what powers? It's the index is 2, so perfect squares. So how could I break up the 2 cubed into a perfect square factor and a non-perfect square factor? It would be 2 squared, right? Times 2. I'm going to put that extra factor of 2 over here. I'm going to group all my perfect squares together. So I'll put that extra factor of 2 over here with a left parenthesis around it. 2 squared times 2. And then what about the 3 squared? Is that good to go? 3 squared is a perfect square, so I'm going to write that right here, 3 squared. Okay, the next base we're looking at is a. In fact, we have a to the 4th power. So is that a perfect square to begin? It is. So we don't need to do anything to it. But what about the b cubed, the base b cubed? How can we break that up into a perfect square factor, non-perfect square factor? B squared times b. I'll put the b over here. And then is c to the 10th good to go? It's good to go. It's an even power. Any even power is a perfect square, so c to the 10th is good to go. So the thing that's going to be left underneath the radical when we're done simplifying is the thing I indicated in parentheses. The parentheses aren't necessary. I'm just putting them there for emphasis. Okay, so let's pull out the square roots. What is the square root of 2 squared? 2. What is the square root of 3 squared? 3. Now remember, the operation is multiplication, so it's 2 times 3 on the outside. What is the square root of a to the 4th? A squared. What is the square root of, I'm going to need a little more room here. What is the square root of b squared? B. What is the square root of c to the 10th? C to the 5th. And it's all right there in front of you. You just have to clean it up now. So on the outside, what should I write? 6a squared bc to the 5th. And then what's left underneath that radical? 2b. So everything's multiplication here, right? It's 6a squared bc to the 5th times radical 2b. Does everybody believe that? Okay. Try simplifying the cubed root of 24, x to the 7th, y to the 4th. Okay, so you broke up 24. Hopefully you rewrote it. So 24 is 2 cubed times 3. So is 2 cubed good to go? Yeah, you're looking for perfect cube powers, right? So you're going to rewrite the 24 as 2 cubed. And then put the extra factor, the non-perfect square factor over here. You don't have to organize it like that, but it's just nice to do it that way. And then how did you guys break up the x to the 7th into the perfect cube factor and the non-perfect cube factor? Yeah, the next perfect cube down from x to the 7th is x to the 6th, and what was left over? Just x, right? X to the 6th times x is x to the 7th. So you're not changing the value of anything. You're just rewriting it in a different form. What about the y to the 4th? How do you have to break that up? Y to the 3rd times y. So do you see how I'm separating the perfect cube factors from the non-perfect cube factors? You don't have to do it that way because multiplication you can do it in any order you want. It's just a nice way to organize your work. All right, so what did you get on the outside? What's the cubed root of 2 cubed? 2 cubed root of x to the 6th?
X squared.
X squared. Cubed root of y cubed? Y. Because I said so. No. Okay. 2x squared, and then what's left inside? Just 3xy. So your final answer should have been 2x squared y. Now, when you write the cube root, try and separate this index from the y, because otherwise it'll look like y cubed on the outside, and it's not. And then you can drop the parentheses on the inside. Just make the radicand 3xy. So 2x squared y times the cubed root of 3xy is your final answer. Does everybody buy that?